Hi, welcome back, guys. I hope everybody's staying safe and staying inside, hopefully, and everyone's family is healthy. I just want to start by giving a shout out to sixth grade for having really good T2 examination scores. We did pretty well on formulas and substitution, even though it was only like 3 questions. We did a good job taking advantage of the scrap paper and answering those questions. But realistically, we didn't spend a lot of time on it, so I just want to finish it up. We'll finish it up in 3 quick lessons, just so we're all on the same page, or you all understand. So that's what we're going to be starting for today, our day one, lesson one lesson. So we're going to go into how to use the formulas and how to routinely show our work. So our agenda today is to work on some phenomena decoding, what's the phenomena mean, criteria for success, some do now thoughts, and tackle some classwork, and then you'll do the exit ticket. So if we're talking about the phenomena, I conveniently placed the picture right here. Probably some teenagers or some kids, adults, whatever. Can't really see. Going around the track on go-karts. Big deal. Okay, great. Let's read the phenomena. A go-kart covers a certain distance in a given amount of time as it moves around the track. Looking at the phenomena, those words as it pertains and it relates to that picture, you're probably looking at me like, okay, that's obvious. Obviously, you're traveling a distance around the track in a given amount of time, right? But let's think about the key words that we want to highlight or shed some focus on, right? The word distance and the word time. Both of them are very important here when considering decoding our phenomena. So what other vocabulary word has to do with distance and time? Or if we're thinking more specifically, what formula is calculated by using distance and using time? Speed. Speed is equal to distance over time. So let's read it one more time. A go-kart covers a certain distance in a given amount of time as it moves around the track. That has to do with speed. How fast are you covering this distance in a given amount of time? Because if, let's say, number 9 is going really slow, let's go 10 miles per hour because that's really slow for a go-kart, right? And number 1 is going, let's say, 45 miles per hour. Who's going to cover the distance in a shorter amount of time? Number 1, because he's going 45 miles per hour as opposed to number 9 that's going 10 miles per hour. So this phenomena has a lot to do with speed. Criteria for success, our favorite. What do we have to get accomplished today? What are our objectives? What are our goals? We have to understand what substitution is and how to use it. Use annotation and why we should use it. Establish a routine to answer substitution questions. So I found that a lot of us didn't know what substitution was, despite us saying like, oh, we use it in math. We're going to see how we use it as it pertains to formulas in science. We're used to annotation and showing our side work. So those are the 2 things we're going to work on today. Annotating the problem and then having a routine or a step-by-step process to show our side work. Do now thought. What does substitution mean? So while you're thinking about this, I'll probably give you like 10 to 12 seconds to think about it, and I'll guide your thinking. Where have you heard the word substitution? Who have you heard it? Where have you heard it being used? Who have you heard it from? How was it being used when you heard it? So I'll give you another 7 seconds to think about what substitution means. Great. So again, I want you to take a look at the photos. On the left, there's a photo of, some everyday basketball playing, regular. And then on the right side, you see what we probably don't want to see. We see some math and some substitution and formulas there. The one on the right is going to be the one that we're going to be handling. But let's start off with the one on the left. And let's read the caption on the left. So while you're playing a game of basketball, your coach notices you're really tired. Dog tired, tongue out, I need water, I have the noodle legs, I'm ready to have a seat, right? You want someone to take your place. So your coach decides to put your teammate in your place. So you're going to take a seat on this bench here, and your teammate's going to come in and take your place. So he substitutes your teammate in, and you take your break. So substitution now means what? someone's taking your place. You're going to have a seat and then have someone take your place on the floor, right? Great. So let's go over to the right side, substitution and math. Substitution in math happens when you have a letter that symbolizes a value, a number rather, and placing the number in its place to solve. So that might be a little wordy. So let's take a look at this fake index card, right? So this is a formula for speed, S equals D over T. So speed equals distance divided by time, like we mentioned in our phenomena, right? So if you're reading a word problem, you have to figure out, okay, I don't know what the speed is. I need to figure out how fast this go-kart was going, right? So let's say the distance, I don't think you would be riding in the go-kart, so let's use something else for 100 miles for 2 hours. Let's say that you, every summer you decide to go down south to North Carolina, Virginia, wherever, you know, your family members live. And they say, well, how long does it take you to get down here? Well, we traveled 100 miles. That was the distance you traveled, right? So you're going to plug in 100 miles for distance, get rid of that, take the place of this D for distance, and you're going to put the number value in here for distance. And then, well, how long did it take you to travel this 100 miles? Oh, what was the time? It took us 2 hours. So you're going to take the T and put the 2 there because the 2 is taking the place of the T. Distance divided by time. Like I said, when you're reading it, find the distance, find the time. Once you find that, put it in the place of distance and put the number in the place of time. So here, let's proceed in this. You have the distance over the time now, but now they're represented by numbers. 100 miles divided by 2 hours gives you 50 miles per hour. That's the speed it took you to come down here. So again, as you're telling the story to your family, yeah, we traveled the distance of 100 miles. How long did it take you? It took us 2 hours. Well, how fast were you going? 50 miles per hour. Okay, and we're going to delve in a little bit deeper on how to solve these problems step by step. It's not necessarily going to look like this. It's going to make a lot more sense when we're being a lot more thorough. That's why we're going to practice our criteria for success for creating that routine. Question 1. Miss Reed wants to go to the grocery store to make a dish at her dinner party. Don't sleep on me, I can cook. The distance from the store from her home is 1,200 kilometers or 1,200 kilometers. The time it will take her to get to ShopRite is 4 minutes. Given the distance and time, what is my speed? So I know that we want to go to the grocery store. I don't know, I want to make a dish for the dinner party. Not really that important. We have to figure out what's important here. So let's keep going. Number 1, what's most important to start off with your routine is annotate your problem. I know we annotate you guys to death, but it really is important to breaking down such a word problem because sometimes we get intimidated by all these words like, Ms. Reed, what's important and what's not, right? So let's annotate your problem. What is the question asking? So annotate, they're asking, what is the speed? What's the speed? What is going to be the speed you're traveling, right? What details do we have based on the formula? So we know that speed is equal to distance over time, or speed is equal to distance divided by time. I mean, it is distance over time, but I want you to use divided by time because sometimes we forget. So the distance here is 1,200 kilometers. The time is 4 minutes, which is why I have this conveniently highlighted because we need to figure out what the speed is, we need to figure out what the distance is, and what the time is. Great. So decide which formula we need. Obviously, it's speed. And how do we make that decision? We made that decision because literally the last 4 words says what would be my speed. So you know we're looking for speed, so we need to use that speed formula. Great. So here's where you want to start breaking down to get to your equation. So we know that the formula was speed equals distance divided by time. So you right here, distance was 1,200 kilometers and our time was 4 minutes. Ms. Reed, why are you highlighting kilometers and minutes? Those are our units. We're going to carry those everywhere. So while you're doing your work, carry those units. If you forget them, your answer's wrong. Always. So your equation you plugged in for distance, we substituted distance. Our distance was 1,200 kilometers. So we substituted and put it 1,200 kilometers in the place of distance. Divided by, we kept our divided by sign. And then we substituted for time, 4 minutes. So we all can do that in our heads. 1,200 kilometers divided by 4. So 1,200 divided by 4 is 300 kilometers per minute. So I'm traveling at a speed of 300 kilometers per minute. All right. Now that we took a look at how to do our work, what is wrong with this scholar's work? It says, now this wasn't done by Siriana. This was done by me. It's a faulty piece of work. Siriana created a small go-kart for the science fair. She tested it on the Great Oaks Legacy basketball court that we all miss and love. I remember shooting the lights out there on you guys because you guys can't shoot. It traveled 500 meters west for 5 seconds. What was the go-kart's velocity? So now here we're looking at velocity. So she provided, well, the scholar provided a formula. Velocity equals distance over time. It's good to me. The equation with the units, 500 meters over seconds, and then the answer. So let's take a minute. I'll give you maybe like 10 seconds to look at this. And what's wrong? Think about the routine that we just went through. What's missing? Let's take a look. There were no annotations here and no units in the answer. So I took the liberty to fix it. You have the annotations up top, 500 meters west, because we're talking velocity and it has to do with direction, right? For 5 seconds, and that's our time. So what was the go-kart's velocity? We had to highlight velocity because we have to know what formula we're looking for and what we're solving for. So the formula was absolutely correct. Velocity is equal to distance over time. The equation was cool because it included the units, the meters, and the seconds, and it also was placed and substituted correctly. Great, but your answer was missing that meters per second west. You need that there. All right. All right, so this is a coaster at Six Flags Great Adventure and conveniently placed in New Jersey, so we can go there once we're out of this quarantine. This is one of my favorite coasters at Great Oaks, at Great Adventure. And at Six Flags, the Nitro coaster's velocity goes from 0 meters per second at rest, because if you're at rest, where are you going? You went 0 meters, you didn't go anywhere yet, to 220 meters per second in 11 seconds. What is the coaster's acceleration? So use the criteria for success to complete the formula substitution, meaning we're going to go through those routine steps each time. I know in math that you guys call it side work, and you guys do annotations. We're going to do the same exact thing here. Great. Let's annotate. What do we annotate here? What do we see? 0 meters per second, 220 meters per second, 11 seconds, and what we're solving for and what formula we're going to have to look out for, acceleration. Number 2, choose the formula. So obviously we're choosing the formula for acceleration because that's what we need to solve for. And that's final velocity minus initial velocity over time. So the next part we're going to take our time with because this can be a little tricky. So writing your equation. So here people often get mixed up with final velocity and initial velocity. You have to think of it as this. The word initial means where you start from, where you originate from. Where are you starting? Where's the start line? Where's the the starting point? And where's the finishing point? So obviously, like I said before, if we're at rest, we're at 0 meters per second. That's where we started from. We're in the barrack, in the coaster, putting our seat belts on, right? At 0 meters per second. We're not going anywhere. That's the initial velocity. That's where we started. Where did we end? The final velocity. Final means ending. the end all be all, right? So that would be 220 meters per second. So even if you look here, from 0 meters per second to, as it took off and started going up the hill, right? You went, or if it goes up a hill or around the bend, I'm not sure, I don't remember. It goes to 220 meters per second. That's our final. So you have to think about, when you're looking at these word problems, look at these key words that I circled in red, from and to. So we know from has to do with it's starting from somewhere. Keyword starting from somewhere. You started at 0 meters per second. Your feet are dangling. You're waiting for them to flip the switch so you can go, right? Then as you're accelerating, you accelerated to 220 meters per second. So that's 2. So that would be your final. And then we just documented our time, which was 11 seconds. So then we wrote our equation. Our final velocity was substituted as 220 meters per second. And our initial velocity was 0 meters per second over 11 seconds, because that's our time. Our time should be 11 seconds. Our answer with units, emphasis on with units. You need the units. Don't forget the units. So here our answer is 20 meters per second squared. Okay? Great. Last but certainly not least, what did we learn today? Our whole criteria for success had to do with what is substitution, understanding why we need it, annotations, why we should annotate, and creating that routine. So substitution is when a number takes the place of the symbol. Like we said before, distance and time. You need to figure out what number represents the distance and what number represents the time. Additionally, we learned a routine. Annotate, find out what our formula is, choose it, write our equation, and give our answer in units. Great. So now that we're at the end of the lesson, I want you to navigate to Google Classrooms to fill out your exit ticket and submit it before class ends. I'll give you about 5 to 6 minutes to do so. Thank you so much for attending and paying attention. If there's any questions, please email me or utilize the Google Classroom platform to send me a message.